Hello viewers, Wagadaruna taking you through the story of O-level mathematics. And this video, we're going to go through the topic of Surds, which is suitable for students in Senior 2, Senior 3, and Senior 4. So before we start, let's first look at the course outline for O-level mathematics. So Senior 2 topics are 11, and these are the topics. So what is ticked is what has been covered. Senior 3, there are also 11 topics, and Senior 4, they are 6. So what is ticked is what has been covered, and you can get it at the end of this video. Of course, there will be end screens like this. So if you want a topic of Senior 2, just double click on this. If you want a topic of Senior 3, just double click on this at the end of the video. So today we are going to look at this topic of Surds, which is under Senior 2 math topics. So expressions such as square root of 4, square root of 9, square root of 16, etc. can be evaluated exactly and have exact numerical values. For example, square root of 4, we all know it is plus or minus 2. Square root of 9 is plus or minus 3. Square root of 16 is plus or minus 4, and so on. However, there are expressions such as square root of 2, square root of 3, square root of 5, etc. which cannot be evaluated exactly and hence can't be written numerically as quantities. So these are irrational and can only give decimal approximations, i.e. if you get your calculator and you press square root of 2, you'll get a value like this, which is 1.414213562. And if you press square root of 3, you'll come up with this value, and square root of 5 will give you this value. So such irrational expressions are what we call surds, and that's what we shall look at in this video. So they often arise in calculations, and it's often preferable to leave an answer in surd form instead of its decimal approximation, since they are many decimal places. However, expressions involving surds have to be simplified following the rules below. So there are some rules which you need to know while dealing with surds. So let's start with the reduced form of a surd. So here we shall write and say that surds can be reduced to their simplest form if the number under the square root sign is a product of a square number and any other number. So square number is like, for example, if I say 2 squared, I'll come up with 4, meaning that 4 is a square number. 1 squared, I'll come up with 1. So 3 squared, I'll come up with 9, meaning 9 is a square number, etc. Therefore, if it is in this form where 1 is a square number and the other one is any other number, I can easily pull this one outside, because this square root of a squared will become a. That is why here you no longer see a squared, you see a, because it is now outside the square root. For example, if I have a number like square root of 175, 175 is the same as 25 times 7. If you get your calculator and you press 25 times 7, you'll come up with 175, meaning that, and this 25 is a square number because it is 5 squared. Therefore, that means that when this one comes out, the square will cancel the square root and you remain with only 5. Then this one will remain under the square root because it is not a square number. So in that, you'll have reduced this surd to be in this form. So after knowing that, let's go to now the arithmetics, multiplication and division of surds. So surds of the same order can be multiplied or divided. For example, if I multiply square root of a times square root of b, it implies that both these ones can go inside one square root, become square root of a times b. Similarly, square root of a divided by square root of b means that these two can go into one square root, which is square root of a divided by b. For example, if I have square root of 7 times square root of 2, these 7 and 2 can go under one square root to come up with square root of 14. Similarly, square root of 15 divided by square root of 3, these 15 and 3 can go inside one square root, and 15 divided by 3 gives you 5. That's why you see a square root of 5. Now furthermore, if I have some value which are outside the square root, they can also be collected together to come to be outside the one square root. For example, this c and this d is outside, so I'll first multiply c times d. Then for this square root I have a and b, so I'll put the a and b under one square root. Let's look at an example. If I have 2 root 7 times 3 root 2, it means that this 2 and this 3 will multiply together to give you that. Then this 7 and this 2 will multiply together and to be under one square root. Then 2 times 3 is 6, and 7 times 2 is 14. That's why you come up with 6 root 14. So that was division and multiplication. Let's look at addition and subtraction. So sides of the same order with the same number under the square root sign can be added or subtracted. For example, remember the condition is that the number under the square root sign must be the same. For example, this is root c and also this is root c. Both have c inside the square root, meaning that they can be added by factorizing out root c, and you remain with a and b, which is here. Similarly, the same applies to subtraction. So it will be a minus b, which is here. Then this common square root will be outside. For example, if I have 7 root 3 plus 5 root 3, realize that this root 3, meaning that this 7 and this 5 can be added together to come up with 12 root 3. Similarly, when I subtract, it means that this 7 and this 5 can be subtracted to come up with 2 root 3. So something we need to note is that root a plus root b is not equal to root of a plus b. So most students confuse it, and they think that when they add two squares which are different orders, you can get this, which is not okay. This one, it only applies if this is a multiplication sign, so here there will also be a multiplication. But if it's addition, you cannot do that. Same applies to subtraction. You cannot do that unless it was division. So with that, let's go through some of the questions. Question 1 came from UNEB 2010. Paper 2 question 1 says simplify this and give your answer in the form a root b, where a and b are constants. So first of all, 20 is the same as 4 times 5, and 45 is the same as 9 times 5, and 125 is the same as 25 times 5. Now the reason why I'm doing that, because 4 is a square number, 9 is a square number, and 25 is a square number. And remember, 4 is 2 squared, meaning that 2 can come out. Then 9 is 3 squared, meaning that 3 can come out. And 25 is 5 squared, which means that 5 can come out. So that you realize that this is the same side, root 5, root 5, root 5, meaning that I can add these ones which are outside the square root, and that is 2 minus 3 plus 5, which is here. Then put this root 5 outside. So this one gives you 4, and this one is maintained to give you 4 root 5, and that's what they wanted. Then question 2 came from UNEB 1999, paper 1 question 3, and says show that this is equal to that. So you start from the left hand side. Left hand side is this, so you come and write it here. Then you remember that 18 is the same as 9 times 2, 50 is the same as 25 times 2, 72 is the same as 36 times 2. Now 9 is a square number. 9 is 3 squared, so 3 can come out. 25 is 5 squared, meaning 5 can come out. And 36 is 6 squared, meaning 6 can come out. Then this root is the same, root 2, root 2, root 2, so it can come out. Then you remain with 3 plus 5 minus 6, which is here. And when you simplify this, gives you 2, you maintain this one to give you 2 root 2, which was required. Then question 3 says that simplify this, leaving your answer in Surd form. So still we shall do the same. 45 is the same as 9 times 5, this is the same as 4 times 5, and this is the same as 16 times 5. Therefore 9 is 3 squared, so 3 can come out. 4 is 2 squared, 2 can come out. 16 is 4 squared, 4 can come out. Now here there is this other 3 because 3 was already here, so it is maintained here and it's also maintained there. Then here you realize this is root 5, root 5, root 5, meaning that you can say 3 plus 6 minus 4, which is here, and you maintain the root 5. Now this one gives you 4, so in the end you come up with 4 root 5, which they wanted. So now we shall go to question 4, which says without using calculators or tables or calculator, simplify this. So this one is the same as 81 times 3, this is the same as 36 times 3, this is the same as 25 times 3. Now 81 is 9 squared, that's why you see 9. 36 is 6 squared, that's why you see 6. 25 is 5 squared, that's why you see 5. Then all is root 3, root 3, root 3, so it can come out. Then you say 9 minus 6 plus 5, which is here. So in the end you come up with 8 root 3. Then question 5 came from UNEB 2005 paper 1 question 3 and says without using tables or calculator, simplify this. So this one has some fraction. Okay, so now 30 is the same as 6 times 5, and 35 is the same as 7 times 5. Then from there I'm going to split this one to become root 6 times root 5, and this will be root 7 times root 5. Then from there I realize that this and this cancels, this and this cancels, remain with root 5, and also here root 5. So these are 2, so 1 plus 1 is 2, that's why you see here 2 root 5. Then question 6 came from UNEB 2003 paper 1 question 2 and says simplify this as far as possible. So first of all, 63 is the same as 9 times 7, and this is the same as 4 times 7, this is the same as 25 times 7, and this is the same as 9 times 7. Then from there, this is 3 squared, so 3 comes out, 2 squared, so 2 comes out, 5 squared, so 5 comes out, 3 squared, so 3 comes out. Then from there, this is root 7, so it means that 3 plus 2 gives you 5, that's why you see a 5 root 7. And here root 7, so 5 minus 3 gives you 2, that's why you see here 2 root 7. Then from here, this and this cancels, you remain with 5 at 2, which can either, so you can either stop here or you write it as 2.5, which is okay. Then question 7 came from UNEB 1997 paper 1 question 8 and says simplify this. So the first thing to do is to get the LCM. LCM of these two is the product, so we're going to multiply the two to come up with that. Then from there, this LCM divided by this, you realize that this cancels with this, so remain with root 3 minus root 2. So root 3 minus root 2 times 1 gives you this part, 1 times that. Then similarly, LCM divided by this cancels with this, so remain with this, which multiplies by 3 to give you this other part. So now next is to expand. For the numerator, we shall come up with this, and for the denominator, it is difference of 2 squared, so it becomes root 3 squared minus root 2 squared. Now simplifying the numerator gives you this, and denominator gives you that. And this 3 minus 2 is 1, therefore you remain with this, which is root 4 root 3 plus 2 root 2. Okay, so now we shall go to the next part, which is rationalizing the denominator. So the process of converting an irrational denominator to a rational one is known as rationalization. Irrational means it has a surd in it. So when fractions are involved with surds, it is normal practice to eliminate surds from the denominator, and this is called rationalizing the denominator. So always remember that a surd must never be left in the denominator when you are writing your final answer. You have to rationalize so that it's no longer there. So the aim is to ensure that the denominator is clearing of irrational numbers. Therefore, for expressions in this form, we multiply the numerator and denominator by root a, which is the denominator. So when you do that, for example, if I have 1 over root a, I multiply both up and down by root a to give me this step. So 1 times this gives you root a, and this gives you a. So in this case, the denominator is now rational, it does not have surd. For example, if I have 1 over root 3, I multiply both up and down by root 3 to give me root 3 over 3, which is okay. So that was one example of a fraction, but also there's another form of fraction where the denominator is in this form. For example, a plus or minus b root c, so it can be a plus b root c or a minus b root c, where a, b, and c are integers. So in that case, we multiply both the numerator and denominator by the conjugate surd of the denominator. For example, conjugate surd, what does it mean? It means that you look at the sign on the surd. So if the sign is plus, the conjugate will be minus. Similarly, if the sign here is minus, here the conjugate will have a plus. So that's what they call a conjugate surd. Therefore, if I have this fraction, I have to rationalize to remove this surd from the denominator. So what I do, I multiply both up and down by the by the conjugate surd, which is a minus b root c. So when I do that and expand, I'll come up with this, which will be the answer. So in this case, I think realize that there is no surd in the denominator. So by that we shall have rationalized. For example, if I have this, it means that now this is plus, so the conjugate surd will have a minus, as you see it here. So apply up and down, then open brackets. Now here I realize that this is difference of 2 squares, so it will be 5 squared minus 2 root 3 squared. So when you simplify, you'll come up with this. Simplify further, you come up with this, and then when you split the numerator, you'll come up with this. So you can either stop at this point or at this point, depending on the question asked. So with that, let's go through some of the questions. Question 1 came from UNEB 1995, paper 1, question 9, and says, given this is equal to this, determine the value of a. So we are going to first deal with the left hand side. So left hand side is this, so come and write it. Then you remember that here the surd is in the denominator, so I have to rationalize in this form. Then this is root 20, which is 4 times 5. Then from there, this and this gives you 5. So when I multiply, I come up with 5, which is here. And this one gives you 2 root 5. Then from there, this and this can cancel, remain with root 5 alone, and this is 2 root 5. Now this is root 5, this is root 5, meaning I can add 1 plus 2 to give me 3, which is here. Then you maintain the root 5, and that will be the answer. But remember, they told you to get the value of a, so I'll come and compare. And when I compare this with this, root 5 is already there, so the remaining part is root 3, sorry, is 3 and a, therefore a is equal to 3. Then question 2 came from UNEB 2017, paper 2, question 5, and says, express this in the form a plus b root 2. So you have to rationalize the denominator. So to rationalize here, the surd has a minus, therefore the conjugate surd will have a plus, as you see here, both up and down is multiplied. Then when I expand, open brackets here, I'll come up with this, and this will be difference of 2 squares, which is that. So in the end, I'll come up with this as the answer in this form, which was required. Then question 3 came from UNEB 2009 paper 2 question 7 and says express this with a rational denominator. So rational means you have to rationalize the denominator. So here in this case the conjugate, this is minus, so it will have a plus. So both up and down are multiplied by the conjugate side. Then when I open brackets here, I'll come up with this, and this one difference of two squares, I'll come up with that. Then simplify, I'll come up with this as the answer. Then question 4 came from UNEB 2004 paper 1 question 2 and says if this is equal to this, find the value of A and B. So first of all, in the denominator there is a surd, so I have to rationalize by multiplying both up and down by the surd conjugate. And when I simplify, I'll come up with negative 2 plus 6. Therefore, I'll compare with this and realize that A is negative 2 and B is 6. Therefore, I'll come and conclude that A is negative 2, B is 6. And that's what they wanted. Then question 5 came from UNEB 2016 paper 2 question 6 and says given that this is equal to this, find the values of A, B and C. So I'll start from the right hand side, which is this. So then I rationalize because there is a surd in the denominator. So rationalize to come up with this step, then difference of two squares in the denominator. Here I'll open brackets, come up with that. Then collect like terms, we come up with this for the numerator and this for the denominator. And in the end, this will be the value, the outcome. Then from there, I'll now compare with this left hand side. So when I compare, A is 9, B is 2, and C is 7. And that's what they wanted. Then question 6 came from UNEB 2006 paper 1 question 3 and says express this in the form this, and hence evaluate this correct to 3 significant figures if root 3 is equal to 1.732. So the first thing to do is to rationalize, and when I rationalize and expand, I'll come up with this, simplify, I'll come up with this. So 4 minus 3 is 1, that is why you remain with negative 1 plus root 3. Then for the hence part, they have given you the value of root 3, so come and substitute for root 3, and that will be the answer to 3 significant figures. So 1, 2, 3, those are 3 significant figures. So now shall go to question 7, which came from UNEB 2011 paper 2 question 11c and says given that root 15 is this, root 6 is this, and root 10 is this, without using a calculator evaluate to 2 significant figures this expression. So that using a calculator means that they want to see you rationalize. Therefore, I'll come here and rationalize. So this is the surd in the denominator, so this conjugate will be this, because here there's minus, here it will be a plus. So multiply up and down to come up with this step. Then from here to here you have to expand, open brackets for the numerator and also use difference of 2 squares for the denominator. So next is to remember that root 15 is this, so I'll come and substitute. Root 6 is this, so I'll come and substitute. Root 10 is this, so I'll come and substitute. Now from here, even if they said without using a calculator, you can use a calculator to add these ones. So why? Because when they say without using a calculator, they want to see this step of rationalizing. So after this step, each student is allowed to use a calculator. So when I use a calculator to add this, I'll come up with 1.161 over 3. Then use a calculator to divide, I'll come up with 0.387, which then I have to round off to 2 significant figures, which is 0.39. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on logarithms for senior 2. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.